Okay, so now we're gonna just do a bunch of practice problems with Pythagorean theorem. So looking right here again, remember I can call this one A or B. This is a leg, this can be A or B. This has to be C. All right, identifying the legs, the hypotenuse, keeping your stuff organized in that manner is incredibly important. But really from there, just writing A squared plus B squared equals C squared, and then just plugging in stuff, all right? 8 squared plus 6 squared equals C squared. 8 squared, 64. 6 squared, 36 equals C squared. Again, keeping your work organized, being very tedious, making sure you're doing the things the correct way. And then C equals a very famous number called 10. Cool. That's it for that. All right. Now, just let's keep cruising right along. Again, you can call this A, B, C. It literally does not matter. A squared plus B squared equals C squared. 3 squared plus 5 squared equals C squared. Doing some computations over here, we get 3 squared is 9, 5 squared is 25, and C squared. All right. Now let me rewrite this a little bit. I'm going to put C squared over here. And then what's 9 plus 25? 34. So C squared equals 34. So we must take the square root of both sides, and C equals the square root of 34. All right. Now, using what we talked about in the first lesson, simplifying radicals, well, the factors, is there a perfect square factor? The factors are 2 and 17. So there's no perfect square factors. So this is actually the most exact answer. This is exact. If it said, give me the exact answer, this is it. It cannot be simplified. All right. If you plug this into a calculator, again, my calculator runs out of screen. I get 5.830951895. Let's just round it to 5.8. This is an estimated or rounded answer. All right. C exactly equals the square root of 34, which is a number incredibly close to 5.8. All right. So we need to know the difference between exact and rounded answers. All right. Nonetheless, let's keep going. All right. This time I have 4B. All right. So 4 is A, B is B, and then remember the hypotenuse is C. So what's interesting about this one is we're actually finding, hold on, let me rewrite this. We have A squared plus B squared equals C squared. All right, I know A is 4, I don't know B, and in this particular case, we have 8.94 squared for C. All right, so realize we don't always have to find C. You can find A, you can find B, you can find any of those letters. All right, in this particular case, we're finding B. So calculating, now I'm going to round just a little bit, 8.94 squared. I'm going to round that to 80. It rounds up to 80 because we have a decimal. But nonetheless, subtract 16. Oops, I forgot this square. Subtract 16 from both sides. I'm going to get B squared equals 64. Take the square root of both sides, and B equals 8. So realize we can find any letter. All right, just don't blindly think the letter we don't have has to be the C, the hypotenuse. We can find the length of a leg as well. And then last one, this is a great one. We'll be talking about more of this stuff a lot in the future. Notice how this gives me A and A. This A is essentially B. All right, so when I have A squared plus B squared equals C squared, in this case, I'm going to have A squared plus A squared equals C squared. This is a right isosceles triangle, all right? So in this particular case, we have C, we have the hypotenuse. Now we need to find the legs of the isosceles triangle. And what a good looking triangle, right? Isosceles, they're just so pretty, so beautiful, right? They're my favorite kind of triangles. All right. So now filling in what I know, I'm gonna have A squared plus A squared equals 7.07 squared. All right, now what I want you to think really fast, does A squared plus A squared equal A to the power of 4 or 2a squared. All right. A to the power of 4 is a common mistake. All right. You might have been thinking that. You might have been wondering why we're not doing that. That's a common mistake. You keep the exponent square and square, and then just realize there's like a 1 out in front. It's 1a squared. 1a squared. You add them together, and that's where you get the 2a squared. All right. So let's just rewrite this. So we're going to have 2a squared, and then 7.07 squared is about 50. All right. Now, another common mistake. Again, been doing this for a while, so I can do it in a video and already know what you guys are thinking. Do you divide by 2 first, or do you do the square root first? What do I do first? Oops, hold on. Didn't mean to erase that. All right, remember, reverse order of operations. All right, I know some of you want to do the square first, but you do SAD MEP. All right, so you're actually going to do the division first. All right, so let's again rewrite this, kind of a cluster going on. But we have 2a squared equals 50. We do the reverse order of operations, which is going to say divide by 2. And look how nice and clean and crisp this comes. A squared equals 25. Take the square root of both sides, and a equals 5. All right. So these are just some basic traditional Pythagorean theorem problems. Finding C, finding a leg, what if it's an isosceles. These are basic stuff. What we're going to do now is some word problems, some really fun word problems. All right. A new pipeline is being constructed to reroute its oil flow around the exterior of a national wildlife preserve. The plan showing the old pipeline and the new route is shown below. About how many extra miles will the new oil flow once the new route is established? Again, so a lot going on here. Let's just emphasize. We have a right triangle. All right, 32 miles we'll call A, 60 miles we'll call B. This old pipeline is C. Remember, it's opposite the right angle. That's how I know that's C. All right, so let's just write A squared plus B squared equals C squared. And then just plugging in the junk I know. 32 squared plus 60 squared equals C squared. All right, I'm going to do all this in my calculator. 32 squared plus 60 squared. So I'm going to get 4,624 equals C squared. And I'm going to take the square root of both sides. All right, I hope I get a nice whole number. Let's see. The square root of 4,624 is 68. Wow, that was nice. Got a whole number. All right, so C equaled 68 miles. All right, round your answer to the nearest whole number. That's something we don't even have to worry about because all we're dealing with is whole numbers. So let's actually do this. New route, I'm going to just write new R for new route, is 60 plus 32, so it's 92 miles. The old route was just 68 miles. All right, so that means the extra miles this new route is, extra M for extra miles, 92 minus 68, which is 24 miles. All right, so oil has to flow an extra 24 miles, but it's worth it. We're keeping the animals safe. All right, we must protect animals at all costs. You guys know what an underrated animal is? I'm drawing an underrated animal right now. It's a skunk. All right, that's a skunk. Skunks are actually pretty cool animals, but they just smell bad. I like skunks. Google a picture of skunks and you'll think they look cool too. Must protect the skunks. All right, in the figure below, triangle ABC is a right triangle. The The length of AB is 6 and the leg of CB is 3. What is the exact lengths in units of AC? All right, so exact. So we'll just call this A, B, and C. Again, it doesn't really matter what you call things, all right? We know we have the hypotenuse, so it's always good to identify the hypotenuse. In this case, we're not finding the hypotenuse. Kind of people just kind of pigeonhole it and always thinks we're finding the hypotenuse. That's not true. All right, after I subtract 9 from both sides, I'm going to get a squared equals 27. All right. Now it said find the exact length. All right. So if I do this, I get A equals the square root of 27. Now square factors. All right. That's a horrible looking A. All right, square factors, remember those are 1 never helps, 4, 9, 16, 25, so on and so forth. Are there any perfect square factors? Yes, 9. 9 is a square factor, so I can break this up into the square root of 9, the square root of 3. Remember, you always write the perfect square factor first. They're both under square roots. What's the square root of 9? 3. The square root of 3 cannot be reduced, so that's exact. All right, we have to differentiate between exact and estimate. This is the answer. All right, estimate is about 5.2. This is rounded, not exact. Read the directions, know what we're finding, know if you can just put it into a calculator or if you actually need to calculate it. All right, and the bottom of the ladder must be placed 3 feet from a wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? All right, so we got our cool blue ladder right here. Here's a ladder. All right, it's touching a yellow wall. So drawing a picture, access your inner artiste. All right, it must be 3 feet from the bottom of the wall. Why? Because, all right, the ladder itself is 12 feet long. All right, we need to know this right here, question mark. All right, so again, looking at this, we have a right triangle. All right, we have a right triangle. So then I can call that A, B, C. A squared plus B squared equals C squared. So 3 squared, we don't know B, and then 12 squared. And then it's just computating. B squared equals 135. So doing the square root of both sides, we get B equals the square root of 135. Now, if I have B equals the square root of 135, we'll practice getting an exact answer. Again, you could play around with this, but eventually it's going to break out into the radical 9, radical 15. Remember, you can just brute force do 135 divided by 1, 135 divided by 4, 135 divided by 9, 135 divided by 16. That's sometimes just the way you find the largest square factor, and we get 3 radical 15. Exact. And then rounded would be the square root of 135. It's approximately 1.6, which is rounded.